or shell. Non-metals have low electron gain enthalpy.
Okay. Yes, you can add.
Metals are elements which have either one, two, or three electrons in their outermost shell. They are also they also give give electrons out and form electropositive charge, which are cations. They form cations, and they're also low ionization. Metalloids show
They have
properties
low
of
ionization energy.
low ionization energy. Metalloids show properties of both metals and non-metals. Non-metals are elements which most will have either 4, 5, 6, or 7 electrons in their outermost shell. They usually gain electrons and form electronegative uh, energy, which is anions. They have low energy, uh, low electronic energy.
They have low electron gain enthalpy.
Yeah, non-metals.
Okay. So that's we're going to have some questions over it. Let's have some questions. Okay. Which one is correct here? Question number 17. Question number 30, which one is correct?
Z is a non-met. Sorry.
Sir, option D.
Yeah, Y is a non-metal. Z is a metal.
Y is a non-metal and that is
Metal.
metal. Okay. Option is correct. Next, let's further have a look on these properties and just memorize it fast. Here on the chemical properties of physical properties of metals. That metals have low melting and boiling point. Okay. Iridium has the lowest high melting and boiling point. Iridium has the highest density. Lowest is of lithium. Okay. Gallium and cesium are the metals that have low melting and boiling point. Mercury is the non-metal that is liquid at room temperature. Malleable means that it can be drawn into thin sheet. Ductility means in thin wire. The most shiny metal is silver. The most ductile metal is gold. Okay. Metals are generally hard, but there are some metals that are soft that they can be easily cut with the help of knife. They are alkali metals like sodium and potassium. So memorize it fast. I will listen it from this. Done?
Yes.
Okay. Next, the properties of non-metals. Non-metals are generally bad conductor of heat and electricity, but graphite is an allotrope of carbon, which is having good conductor of heat and electricity. Let me explain you that why graphite and okay is good and bad conductor of heat and electricity. Let me explain you. So if I'm talking about the carbon, okay, carbon when arranged in a hexagonal structure like this pattern. So it is the arrangements of carbon in graphite structure. In this way, carbon is arranged in graphite. Okay. Okay, they are arranged like this. And similarly, there is another layer that is formed here like this. You will notice here that this is the first layer of graphite and this is another layer of graphite. And these two layers are placed on one another like a paper in a paper bundle or a note bundle. We have notes, okay, currency notes, like pages in your copy. And the main difference here is that this layer is placed over this layer and they are not having any bond between them. They are not having any bond between them. They are arranged like this. Okay, they are arranged like this. This is placed. The one layer is placed over the another layer. and there is a huge difference between the one layer and the another layer. Okay, so these atoms are not bonded directly with them. They have weak force. And look at this, that each carbon atom is bonded with three other carbon atoms. Like you see that one carbon atom is bonded with three other carbon atoms here. So this is the first carbon. It is bonded with one carbon, second carbon, third carbon. This carbon is bonded with 1, 2, and 3. This carbon is bonded with 1, 2, and 3. Okay, this carbon will be also bonded with another carbon here. And this will be also bonded. This will be also bonded. This will be also bonded. So in graphite, each carbon atom is bonded with three other carbon atoms, leaving an electron unbonded or free. Like this. And you know that a diamond, in graphite, an atom cannot be stable. Carbon atom cannot be stable with three bonds. It must make 4 bonds in order to attain stability. Because carbon, when it is making 4 bonds, then the 4 electron will be in its sharing bond, and 4 means 8 will be there. So we'll simply say here that here the carbon is bonded, okay, and as a result of which, in order to attain the stability, it make alternate double bonds. It make what it makes? It make alternate double bonds. Like one carbon make bond with this one. So here, since these 2 electrons are being participated, now this electron cannot participate with this one. So it will be alternate double bonds. And this alternate double bonds make the structure of graphite stable. Every carbon atom is bonded and there is an alternate double bond there. It is not making bond with this carbon. They are not making bond. They are very, the distance between the 2 layers is very far. The atoms are having large distance between them. So they cannot, they are just placed together, and they can just slightly move over each other, but they cannot make bond. Because atoms of this carbon and this carbon atom is having a great distance. So they cannot make bond with this carbon atoms. Now what happened is that now it is making 4 bonds and all the electrons are participating now. So how can we say that it is still good conductor of electricity? The reason behind it is that whenever there is in chemistry, whenever such condition arises, when there is an alternate double bond is formed, like first bond, second bond, double bond, then zinc, then is alternate double bond. Then after some time, where there is double bond, it will be a single bond, and where is single bond, it will be double bond. This process remain continuous. The structure goes from this one to this one and this one to this one. It goes doing like this. Where is double bond? Where is there is a double bond. It is just like, no, just let me show you. Like this is one carbon atom. This is one carbon atom, and this is making bond with another carbon atom. And this is another carbon atom. So like these are the electron clouds where the electrons are revolving. So sometimes they both make bonds and there will be double bond between them. Sometimes they make bond. Like the trees in a jungle, if they are if wind is blowing, so sometimes the tree go like this, sometimes it comes back, sometimes it goes like this, sometimes it goes back. So when this cloud goes and come closer to this one, the bond between these two are formed. And sometime when it goes to this side and this goes to this side, so the bond between these two are formed. And this process remain continuous. Sometimes the electron cloud goes like this, sometimes it goes like this. It keep on going like this. As a result of which, alternate double bonds, whenever there is an alternate double bonds are formed, there is where this single bond it becomes double, and where double it is single. And this is known as delocalization of electron. What we called it? Delocalization of
Sir, is
electron.
that in the syllabus?
What are you saying?
No, are they gonna tell us to prove it?
No, they are not going to. I'm just going to explain you why graphite is good conductor of electricity. Okay. So in graphite, every carbon atom is bonded with 3 other carbon atom, leaving electron free. And this free electron make alternate double bond, as a result of which delocalization of electron take place. And due to delocalization, if electricity is conduction of electricity is possible. When the electron move from one position to another position like this, so they can conduct electricity. Okay, they can conduct electricity. And why in diamond it is not so? Why diamonds are bad conductor of electricity? The reason behind it that in diamond each carbon atom is bonded with four other carbon atoms. There is all single bond between them. There is all single bond between them. In a tetrahedral structure. They are arranged in a tetrahedral structure. Like this way. Okay. And this is known as tetrahedral structure like this. One carbon atom here, one carbon atom here, one carbon atom here. And they are all single bond. There is no all electron are participating in the bonding. No electron is free. That's why they can make bond like this. Okay, they can make bond like this, and they keep on going like this. They keep on doing like this. So in graphite, each carbon atom is bonded with four other carbon atoms. And this structure, this arrangements of carbon, a single element, but in two different forms, is known as allotropes. Diamond and graphites are the allotropes of carbon in which the same kinds of atoms are there, but due to different arrangements, one in a hexagonal structure, it make it graphite good conductor. In here, in tetrahedral structure, it is making diamond and making its hardest substance. Why? Why it is making its hardest substance? Let me explain you. Like one carbon can make bond with another carbon by making four like this way also. In a hexagonal, in a square planar geometry, they can make bond like this. One carbon atom is attached with four other carbon atoms like this. They can attach like this. But here, if you see that this is not the equal distribution of bond angles, or the means there is a partiality that these two bonds are at 180 degree repulsion and these two bonds are at 90 degree repulsion. So why there is a favor for this one and why there is an injustice for these two? Moreover, if you apply the force on this carbon, the maximum force will be exerted on this one. If you apply the force on this carbon, then maximum force will be exerted on this one. So there is not equal distribution of bonds angle. There is 19 between two and 180 between these two. So there is injustice. In the tetrahedral structure, it is the speciality of the tetrahedral structure that it is in this structure, every carbon atom is bonded with four other carbon atoms and having same bond angles. Same bond angle. The angle between this one and this one, this carbon and this carbon is 109.5 degree. This one is also 109.5 degree. This one is also 109.5 degree. This one and this one, every carbon atom is bonded with another. The bond angle between every two bond is 109.5 degree. It is same. It means all the bonds are of same energy and same bond angle. Understood? Yes or no? Yes or no? Understood? And if you apply the force on this carbon, let's suppose if you apply the force on this carbon, it will be equally distributed on all the carbons. If you apply the force on this carbon, it will be equally distributed on all the four carbons. This is the speciality of the tetrahedral structure that make it good conductor of electrons. Sorry, hardest substance. So that's why it is the hardest substance. Understood? Diamond is the hardest substance known due to its tetrahedral structure stability. This is the tetrahedral structure. Draw this structure, please. Done everyone?
Done, sir.
Done? Done
Yes,
everyone?
sir.
Draw the structure of graphite also. Done? Done everyone?
Yes, sir.
Okay.
Yes, sir.
The answer for the first question?
Dullness.
dullness,
Dullness.
Second.
ductility,
Ductility.
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 Next.
A, it,
First. What is the role of electrical conductivity in making utensils?
wait, D,
Yes, we
Uh,
good thermal conductivity and high melting points. Next.
Fe.
Fe,
Fe.
Question number 17.
Hg.
Mercury. Hg.
Mercury. Hg.
$25.
Na. Na.
Na, sodium,
Na. Sodium.
बताइए. Tell me. 31. $31.
Is it Al?
Yes. Aluminium, zinc, and lead are the three metals that have. Okay.
Yes, sir.
Next. Question number 24.
Bromine.
Option B.
B,
Question number 43.
excess carbon,
Axis
is
carbon.
diamond,
Y is diamond. And the
Graphite.
yeah,
Okay. If we're talking about the chemical properties of metals and non-metals, as you know that metals, those metals that are above hydrogen in the reactivity series are able to produce hydrogen gas on reaction with acids. But there is a metal that is HNO3 that do not liberate out hydrogen gas on reaction with acid. Why it is so? Can anybody explain me why HNO3 on reaction with metal do not produce hydrogen gas?
Because HNO3 is a strong oxidizing agent.
So what does it do?
So it
So-
oxidizes the H2 produced to water, and itself it gets reduced to any one of the nitrogen oxides.
Wow, funny, you did well. You did cheated well.
Uh,
You have opened your notebook, and so everyone please memorize this question. I'm going to explain. Ask you first. Why HNO3 do not produce hydrogen gas on reaction with metals? So since HNO3 is a strong oxidizing agent, it oxidizes the hydrogen gas. Okay, it oxidizes the hydrogen H plus ions to form water, and itself get reduced to any of the nitrogen oxides. Okay, such as nitrogen NO2 or N2O5. But there are two metals, manganese and magnesium are the two metals that can react with HNO3 and they can produce hydrogen gas. So please memorize this question. This is very important for the NCERT exam.
they're done.
Yes, you Alvina have done.
Done.
Yes, sir.
Okay. Yes, Susanna.
HNO3 being a strong oxidizing agent when react with metal do not liberate hydrogen gas because it itself gets wait, it itself gets reduced into one of the nitrogen oxides and it evolves the hydrogen gas. But manganese and magnesium do help HNO3 liberate out the hydrogen gas.
Yes, you Mariam.
Yes, sir. HNO3 being a strong oxidizing agent on reaction with metals does not liberate out hydrogen gas as um, it oxidizes the hydrogen gas produced to form water and
It reduce the hydrogen ions.
uh, it reduces the hydrogen ions produced to form water and uh, itself gets reduced to any of the nitrogen oxides like N2O5, NO3, etc. But manganese and magnesium react with very dilute HNO3 to evolve hydrogen gas.
Yes, you're correct. Mariam, you are correct. It oxidized the H plus ions to form water, not the reduce. Okay, you are correct.
Yes, sir.
Yes, you, Alvina.
The HNO3, even though being a strong oxidizing agent, it doesn't liberate the H2 gas because it oxidizes the H2 gas to form water and
Not H2
itself
gas, not H2 gas. H2 gas बनती ही नहीं है. बनेगी तब तो
um,
oxidize करेगा. H plus ions.
H plus
It
ions
oxidize the H plus ions of acid to form water.
and it itself gets reduced to nitrogen oxide such as N2O5, NO3, etc. However, magnesium and manganese, they upon reacting with HNO3, they liberate the H2 gas.
Yes, you do not produce.
It is a very strong oxidizing agent, and it will oxidize the H2 ions to form water, and it itself will get reduced. But if it is with magnesium, then it'll help liberate the hydrogen gas.
Next is that if you know that metals that react with water, they are the fixed condition for them that if it is Na, it react with NaOH, hydrogen gas. If it is reacting with potassium, it forms KOH plus water. With calcium, it forms calcium hydroxide plus hydrogen gas, magnesium hydroxide plus hydrogen gas, and with aluminium, zinc, and iron, it reacts in the form of gas, which is steam, and formed Al2O3 with aluminium, ZnO4 zinc, and iron Fe3O4 plus hydrogen gas. Okay, so here are the conditions. So memorize this condition fast that we're going to discuss the questions over it. And I'm going to ask you that which of the following is going to react with cold water and what is going to form. The first four metal forms hydroxide. Other metals that react with steel, they form only oxide.
So the last one only reacts with steam.
Yeah.
Okay.
Done? Done?
Yes.
Okay. So, Mariam, you are talking with someone?
No, sir.
No, I'm seeing you continuously. You are chatting. You memorized?
Yes, sir.
Okay. Then tell me that what happens when calcium is going to react with water?
Ca plus H2O gives CaOH the whole twice plus